This video, we're going to be discussing graphs of logarithmic functions. So in a previous video, we discussed graphs of exponential functions, and logarithmic functions are going to be very similar to that, because a logarithm is just another way of representing an exponential relationship. So the parent function of a logarithmic equation is y equals the log of base b of x. That's how we pronounce this. So it's log. This little number down here is called the base of x. So b is called the base. Okay, and the way the relationship works is if 2 to the third power is equal to 8, then the log base 2 of 8 is 3. It's just another way of evaluating exponents. They're actually the inverses of exponents. All right, so logarithmic graphs look like this. Okay, logarithmic functions have vertical asymptotes. If you remember, exponential functions had horizontal asymptotes. Logarithmic functions are going to have vertical asymptotes. All right, so if we talk about transformations of logarithmic function graphs, okay, the number out front, once again, stretches or compresses the graph. The number inside of the parentheses with the log moves left or right, with adding being left and subtracting being right. And our number outside of the parentheses moves it up or down, with up being plus and down being minus. And the equation of the asymptote, for exponentials, the equation of the asymptote was y equals k. For logarithmic functions, the equation of the asymptote is x equals h, because they are vertical asymptotes instead of horizontal. So if we take a look at an example, so we want to graph the equation and fill in the characteristics of f of x equals log base 2 of x minus 3 plus 2. So if I graph it, it looks like this. Okay, you would just use points from your graphing calculator. You'll notice that I have this vertical asymptote, okay, right here. Oops, that is not the right color. There we go. So if we draw this in, we've got this vertical asymptote going down right here. All right, and that is at 1, 2, 3. So our asymptote is at x equals 3. You can see that from in here. Right, it's just x equals the h value. So for our domain, range, end behavior, and our y-intercept. So for our domain, it's going forever to the right, but on the left-hand side, it's going towards 3 without ever actually getting there. So our domain is from 3 to infinity. And notice that 3 gets a parenthesis instead of a bracket because it never actually touches 3, it just gets close to 3. For the range, well, it's going up forever and down forever, so the range is negative infinity to positive infinity. For the end behavior, as x is going to infinity on the right, the graph is going up, so f of x is going to infinity. And then on the left-hand side, this says x goes to infinity. This shouldn't even be infinity. X is going towards 3. But f of x, since it's going down, is heading towards negative infinity. And then our y-intercept is at this point right here, which is 3.250. So that's really what you need to know about logarithmic equations. All right, you need to know how they look like, and you need to know that they have vertical asymptotes. And the asymptote is always x equals whatever your h value is.